Major General Sir Percy Hobart and a small group of British and Canadian engineers took ordinary tanks, stripped off very little, and fitted unusual gear. Tanks that could float with canvas skirts, tanks that could shoot a petard demolition mortar to blast concrete pillboxes, tanks fitted with flails to chew through mines, and tanks with flamethrowers to clear bunkers at close range. They became known by the affectionate, slightly mocking name, Hobart's Funnies. Why did that matter? Beaches are not open fields. They are obstacles. High sand berms, anti-tank obstacles buried in sand, narrow exits, and concrete strongpoints. A straightforward tank landing often bogged down. The simple tricks, floating screens so a tank could approach the shore under its own power, a rotating drum of chains to clear mines, a short-barreled mortar to destroy a casemate turned chaotic landings into survivable ones. The very existence of specialized tanks allowed infantry to advance inland when otherwise they might have been pinned to the beach. A few honest points. Not every specially fitted tank worked perfectly. Some flotation devices were overwhelmed by surf, some flails broke, and some crews had to improvise repairs under fire. Still, the sum of these modest adaptations changed the calculus at several key landing sites. Without them, the cost in time, men, and momentum would have been higher. Sherman Firefly turning up the bite on a familiar friend. The American M4 Sherman was a reliable, well-made machine and was produced in huge numbers. But against the German heavy tanks that appeared later, the Sherman's standard gun sometimes lacked the punch. The response, particularly from British tank crews fighting in Northwest Europe, was to fit the Sherman with a long, powerful British anti-tank gun, the 17-pounder. The result was given a nickname, the Sherman Firefly. This was not a science fiction upgrade. It was mechanical ingenuity plus a willingness to adapt, altering the turret and repositioning the recoil system so the larger gun could fit. The Firefly gave Allied formations the ability to engage and defeat heavier German tanks at combat ranges they might otherwise have to avoid. That sounds like a small change, switch the barrel, and the world looks different. But in a theater where a handful of enemy heavy tanks could stall in advance, the adaptation mattered. A simple human trick that mattered as much as hardware was how crews used their Fireflies. They were sometimes kept back deliberately as anti-tank reserves, not thrown in at the head of an attack. One or two effective shots at the right moment could blunt a counter-thrust and let the rest of the force press the advantage. T-34, sloped armor and the truth about design genius. Historical, explanatory. If you travel back to the Eastern Front in the early 1942nd, you'll find plenty of debate about what really turned the tide there. One piece of that answer is the T-34 tank. People talk about it as a marvel of engineering, and part of that is Wright's simple, practical features made it tough to stop and comparatively easy to keep in the field. A few features to note. Sloped armor. Rather than a vertical plate, the T-34's hull and turret had angles that meant an incoming shell was more likely to glance off. That effectively increased the protective value of the same thickness of steel. It was a simple geometric trick, but a huge one. Wide tracks and a robust suspension. These gave it better cross-country mobility in the mud and snow of the Eastern Front than many contemporaries that sank or bogged easily. Diesel engine. Less likely to catch fire than gasoline tanks, and easier to manage logistics in the field in some circumstances. Simplicity of manufacture and repair. The T-34 could be built in large numbers and fixed in basic workshops close to the front. Now, no single tank won the war on the Eastern Front. Nothing that simple happened, but the cumulative effect of a widely produced, reasonably protected, and mobile vehicle was decisive in numerous local battles. The lessons here are twofold. First, small design choices, slope of a plate, choice of engine, have outsized battlefield consequences. Second, numbers and maintainability are victory factors just as weighty as raw ballistic performance. Operation Fortitude and the art of the dummy tank, factual. Not every trick that changed the course of operations was about shooting. Warfare is about misdirection as well as firepower. In preparation for the invasion of Northwest Europe in 1944, the Allies engaged in a vast deception plan to convince the Germans that the main invasion would come elsewhere. It involved radio traffic, double agents, fake headquarters, and yes, inflatable tanks and dummy vehicles. These inflatable or wooden mock-ups weren't meant to fight. They were meant to be seen by aerial reconnaissance, by enemy spies, by radio intercepts. Paired with fake signals and radio chatter and the careful placement of troops and supplies, they made an entire German command rethink where Allied strength was going to arrive. The trick here was the understanding that perception is a battlefield. If you can make the other side concentrate where you are not going to strike, you can lower resistance where you will strike. The Fortitude Plan probably bought time and reduced the concentration of German units at the actual landing beaches. That's not a flashy shootout, but it is a simple, honest technique that affected how men and armor were arrayed when the landings came. Hull down, reverse slopes, and the highway of patience, composite, plausible. Here is a short composite tale, stitched together from many after-action accounts from Europe and elsewhere. Think of it as a head nod to 100 anonymous tankers. A lieutenant and his crew are ordered to cover a pass. A superior enemy force is reported several miles away, and reports speak of heavier tanks. The lieutenant knows his own tank is not the best for a frontal slugfest, so he parks the vehicle with the hull behind the crest of a gentle rise. Only his turret, small, hard to see, pokes over. He angles the track and the hull so that incoming shot will have to climb and will hit slope instead of face. He tells his driver to stay engine off unless necessary. They douse the command lights, cover any shining metal with dull cloth, and the crew trains their binoculars. When the enemy column crests the rise, a lead vehicle appears, solid and exposed. The crew waits for the decisive moment, opens fire with a short, telling burst, and then moves the tank backward into the fold of the hill, engine spitting dust and noise in a different direction to confuse the enemy. They do not engage in a long firefight. They choose moments, angles, and concealment. That hull down and shoot and scoot approach is very ordinary and yet decisive. In many places and times, a clever position and patient discipline were worth more than a heavier gun. It saved lives and preserved vehicles to fight another day. That's the kind of simple cunning that turned local situations from losses into stalemates, and stalemates into controlled withdrawals, all of which matter in the rhythm of a campaign. Desert improvisations, water, sand, and using what you have. Factual, composite. North Africa was an arena of intense mechanical improvisation. The desert is a peculiar adversary. It wears down rubber, chews up cooling systems, and eats bearings for breakfast. Supply lines run long. The Germans and British both learned, sometimes painfully, that the side that could keep its vehicles moving won more often than the side with a better gun. Some real, straightforward practices. Field repairs and cannibalization of parts were routine. A tank that could be made to run again in the next few hours was often worth more than a brand new vehicle arriving a week later. Crews used sand channels, low-speed grinding of gears, and periodic dust seals to keep sand from destroying gearboxes. Camouflage wasn't always about paint. Crews hung tarps, piled sand, and used local rocks to break line of sight. At times, they would dismount a turret to make a tank look like a pile of rubble from far away. These are small, practical acts of survival and a reminder. Fighting a war is a chain of supply and maintenance as much as of tactics. The side that mastered that chain had a strategic edge. Flame, morale, and the Churchill crocodile. Close-quarter bunkers, pillboxes, and urban strongpoints are the kind of places where ordinary guns struggle. A simple trick in the British inventory was the flame-throwing Churchill crocodile. It was essentially a Churchill tank with a flamethrower linked to a trailer of fuel. The effect was psychological as well as practical. A bunker that would not fall to shells sometimes surrendered quickly when faced with a lash of flame. That's uncomfortable to think about, and rightly so. But the military fact is that such weapons, ugly as they were, reduced the bloodletting in certain situations by convincing defenders that continued resistance was futile. The trick here is force multipliers that operate on morale as well as steel and lead. In several operations, knowing that a unit had flame tanks meant defenders chose to withdraw or surrender rather than stand and be burned out. A grim but real way of avoiding higher casualties on both sides. Logistics, crew habit, and why Shermans kept coming back. Historical observation. One of the recurring themes in debates about tanks in the war is this: numbers, habits, and maintenance often beat technical superiority. Shermans were often outgunned by Panthers and Tigers in head-to-head tests, but the Sherman fleet was ubiquitous, rugged, and supported by an immense logistics apparatus. Spare parts were plentiful, crews had good repair discipline, and a broken Sherman could often be fixed and back in hours. A knocked-out Panther, on the other hand, might remain a hulking wreck because spare parts, crew trainers, and fuel logistical networks were fewer. In the aggregate, this is a simple trick. Prepare your vehicles to survive breakdowns, train crews to do field repairs, accept a slightly less perfect weapon when you can have 10 of them all ready to go. That is the kind of strategic and operational thinking, almost banal, that decided campaigns more than the headline-grabbing duel of individual tanks. A small human story about spare parts. Composite. A corporal slides under a tank in the mud, his lamp sputtering. The radio is silent because the radio box has been waterlogged. He finds a makeshift patch and an angle bracket from another vehicle taped with a soldier's handkerchief. He scrapes away mud, fits the piece, and crawls out to bang on the commander's hatch. By dawn, the tank rolls again. That's not a famous story about the war. It's the kind of thing that happened by the thousand, and each time it made a difference. The simple acts of cobbling, patching, tugging a broken sprocket back in line, these small, non-glamorous tricks kept forces moving and put armor back in the fight. The quiet power of deception, radio, smoke, and fake columns. We've touched on inflatable tanks. Another recurring technique was simulated traffic columns of trucks and tanks that were deliberately routed to be seen and heard in places where no actual strike was planned. Puffs of smoke, the sound of engines, and the lighting of campfires in conspicuous places all fed into enemy observation. That's not cheating. It's the simple, lawful work of misdirection. Again, this matters because a motorized division that is held at bay by the fear of armored units in Sector X cannot be brought to bear where the real attack comes. Simple deception buys time and space. During the war, whole operations were shaped by cunning and the ability to create convincing falsehoods in the enemy's head. On courage, improvisation, and small decisions. Reflect. When people recall the tanks of the Second World War, they often imagine roaring engines, gleaming steel, and heroic magazine pictures. What the tank war also consisted of were hundreds of thousands of small acts. A gunner using a rangefinder in the rain, an officer choosing to flit his Firefly from reserve to the forward flank, an engineer welding a chain to a wheel to keep a flail turning, a private laying a damp blanket over a reflector to keep a moonlight glare from revealing a tank's position. These are not romanticized tales of outsized cunning. They are human choices in stress. Choose the right moment, angle the hull, keep the tank's belly away from mine-affected ground, remember to top off the lubricant, place smoke between the enemy and your dismounting infantry. Each choice reduces uncertainty. Together, they accumulate into battlefield advantage. One last composite vignette. The Night Thing. Fictional, but plausible. A small British armored troop takes a small piece of ground in Italy. The orders are to hold the spur until dawn. The enemy counters with a pair of tanks and infantry. Darkness is their friend. The troop's leader orders the crews to run their engines at strategic intervals and then stop them to create a rhythm for passers-by who may think the area is still occupied. They light a single, low, controlled flame on a ridge to suggest a camp. One Sherman is placed hull down, one as a feint behind a ridge, and a third is set about 200 yards back with two infantry sections for close-in defense. The enemy tanks push forward, searching for targets. They spot the hull-down silhouette and close. When they do, a Firefly hidden behind the ridge opens up with a precise, long-range shot. The enemy tank halts and withdraws. The feint behind the ridge, a vehicle with its turret collar banked with brush, draws the other armored element away. The fiery little game is done before dawn. The troop holds the spur. That little episode is imaginary, but every element of it, the timed engine noise, the use of a hold-down position, a hidden Firefly, feinted positions, mirrors real tactics widely used. It reads like a small tactical poem. Economy of effort, deception, patient waiting, and a single decisive use of an asset. Closing thoughts. For someone who remembers. If you're over 60, you may remember men who served in tanks, or you may recall the rusted hulks of old machines standing in parks and museums. The stories in this long telling are both tribute and explanation. Machines were important, but the margin between defeat and victory was often crafted by minor, human-sized tricks. An improvised repair, a well-timed shot, a deceptive dummy, a small engineering change. Perhaps the most important fact is philosophical rather than technical. War is decided by people who think under pressure, not by machines alone. Tanks amplify judgment, they do not replace it. The T-34 slope of armor, Hobart's modified vehicles, the Firefly's long barrel, these are all examples of humans recognizing a problem, devising a modest fix, and applying it where it matters. That is a lesson worth keeping. Crew life inside the steel box. Few images capture the reality of armored warfare, like the inside of a tank. Claustrophobic, noisy, oily, hot in summer and freezing in winter. People sometimes understate how much the human element determined outcomes. Roles and teamwork. A typical medium tank crew in World War II often had 4 or 5 members. Commander responsible for situational awareness, target selection, and communicating with higher command. Gunner aimed and fired the main weapon. Loader handled ammunition and prepared rounds. In automatic loading tanks, this role was different, but World War II was largely manual loading. Driver maneuvered the vehicle. Visibility was often limited to periscopes and hatches. Radio operator, bow, machine gunner, in some designs, a 5th team member handled communications and a forward machine gun. Each role required training and calm under sudden stress. The commander's ability to synthesize noisy, fragmentary information and choose a course of action was as decisive as the gun's caliber. Small signals mattered. A hand gesture, a brief radio call, a whispered report from the driver. These are the pieces that turn steel into coordinated force, living conditions, and morale. Tanks are uncomfortable for weeks on end. Fuel and oil vapors, kerosene from heaters, and the ever-present scent of grease and metal create a sensory environment that wears on nerves. Crews developed rituals, cleaning routines, wiping periscopes, oiling, moving parts, stowing tools, partly to keep machinery reliable and partly to create a predictable rhythm. Shared jokes and stories to keep fear from becoming paralyzing. Fast, practical rituals for readiness. Keeping a charged, wrapped spare shell near the loader's hand, always carrying a small sack of food or a thermos, a small religious token or keepsake under a seat. These habits matter because combat is as much about human endurance as it is about weaponry, anti-tank threats, and countermeasures. Tanks do not fight in isolation. The rise of specialized, inexpensive anti-tank weapons throughout World War II brought new dangers, and both sides adapted. Infantry anti-tank weapons. Weapons like the German Panzerfaust and Panzerschreck, the British Piat, and the American bazooka were simple, man-portable devices that could defeat armor at typical assault ranges. Their appearance changed tactics. Tanks had to coordinate closely with infantry to prevent enemy teams from getting close enough to fire. Urban and broken country fighting became particularly dangerous, as infantry could conceal themselves and fire from ambush. Crews used added skirts, sandbags, and stowage on the hull to reduce the risk of penetration into crew spaces. Limited effectiveness, but something. Air-delivered threats. Close air support could be lethal. Fighters like the Soviet Il-2 Sturmovik, the US P-47 Thunderbolt, and German Ju-87 Stuka could deliver rockets, machine gun strafing, and bombs that, while not always penetrating heavy armor, were highly effective against exposed vehicles, softer vehicles, supply columns, and infantry. This is why dispersal and cover became important. Parked tanks in the open were inviting targets. Anti-aircraft coverage over armored formations reduced vulnerability and forced attackers to fight through layered defenses, mines, and assault engineering. Anti-tank mines were a constant hazard. Engineers and sappers developed and deployed mine-clearing methods pinned to the concept of making a lane rather than clearing a field. Mine-clearing tanks, mine rollers, and pioneer teams working with probes and detonation methods were all part of the toolbox. The psychological effect of mines slowing advances, shaping routes, was often as important as the physical damage they could cause. Armor layout, ammunition, stowage, and survivability. A recurring topic in debates about World War II tanks concerns survivability when hit. Two design choices had major effects. Ammunition stowage. Where shells and propellant were stored mattered. Tanks that stored rounds in sponsons or in hull racks that ran along crew compartments could be catastrophically vulnerable. A penetrating hit could set off stored propellant and cause a fireball, the dreaded brew-up. Some designs used armored, isolated bustle racks in turrets, wet stowage with water or glycol to blunt fire propagation, or semi-encased ammo bins to reduce that risk. These choices could seem minor in the design phase, but had life or death consequences in battle. Slope versus vertical armor. Sloped armor, as used notably in the T-34, offered greater effective thickness without weight penalty. The geometry mattered more than absolute thickness in many encounters. Angle can turn a direct hit into a ricochet. Trade-offs in design. No tank is perfect. Designers always balance protection, firepower, mobility, and logistical footprint. A heavily armored, slow tank might be unbeatable head-on, but easy to sideline in difficult terrain or when fuel is scarce. A lighter, faster tank might dominate in certain maneuver battles, yet be vulnerable in a slugfest. Commanders paired tanks with doctrine and support to compensate for those weaknesses. Doctrine and the national styles of armor employment. Different combatants used armor with different doctrines reflecting pre-war thinking, industrial capacity, and operational needs. German Schwerpunkt and combined arms. German doctrine emphasized the Schwerpunkt, a point of main effort, using armored formations to punch through weak points and exploit rapidly. Mechanized formations were tightly integrated with infantry, engineers, and aircraft, Stuka close support early in the war. The result was operational flexibility and the capacity to create local superiority. There were weaknesses: increasing complexity, logistical strains, and vulnerability to counter-concentration. Soviet deep battle and mass. The Soviets developed deep battle theory, combined arms operations intended to penetrate tactical defenses and follow through with operational encirclement. This required massive production, the ability to absorb losses, and a focus on mobility and numbers. The T-34 fit this doctrine: robust, mass-produced, and repairable. Western Allied emphasis on logistics and integration. British and American doctrine iterated around the idea that mobility and sustained resupply could win long campaigns. Shermans were not always individually superior, but backed by logistics, air cover, and artillery, they formed a persistent offensive presence. Allies also borrowed and adapted, demonstrating flexibility. Sherman, Firefly, and Hobart's funnies are examples of doctrinal and engineering adaptation to solve battlefield problems. Notable battles and what they taught. Kursk, July 1943. The Battle of Kursk was the largest tank battle in history, and a study in prepared defense versus concentrated attack. The Soviets, having early warning, prepared deep belts of anti-tank obstacles, minefields, and anti-tank guns. German forces, with concentrated armor and air support, faced a layered defense they could not break without high losses. Lessons. Prepared defenses in depth can blunt the advantage of a concentrated armored thrust. Logistics and attrition matter. Without sufficient reserves and repair capability, an attacker can bleed to failure even if they locally achieve objectives. El Alamein, October-November 1942. In the North African desert, mobility and logistics were king. The British Eighth Army, supplied through improved logistics and with effective combined arms operations, finally broke the Axis linear defense. Lessons. Supply lines, fuel, water, ammunition shape possibilities in desert warfare. Engineering and maintenance become decisive over long supply routes. Normandy and the Bocage, June-August 1944. Normandy's hedgerow country turned open field tank tactics into a close quarter fight. Tanks operating without close infantry support were highly vulnerable to anti-tank teams. Innovations like the Rhino hedgerow, cutter, a reel, improvised device of welded tusks attached to Shermans allowed vehicles to breach hedgerows and regain mobility. Lessons. Terrain can make doctrinal use of tanks irrelevant. Adaptation is essential. Small engineering fixes hedgerow cutters can restore operational flexibility. Italian campaign and broken country. Italy's mountainous and urbanized terrain highlighted mobility problems for armor. Narrow roads and confined valleys limited maneuver, making combined infantry and armor tactics indispensable. Tanks often supported direct assaults on fortified positions, and engineers had to provide bridging and road clearance for continuous advances. Improvisation, local adaptation, and the role of everyman engineering. The war is full of stories where low-technology improvisation had outsized effects. These range from welded panels to redirect track debris to simple camouflage that fooled reconnaissance. A few examples. Desert crews lining tanks with locally sourced materials to reduce dust ingestion. Units using farm tractors and ropes to recover disabled tanks when purpose-built recovery vehicles were unavailable. Rifles and grenades converted into makeshift demolition charges for obstacle clearance. Such innovations reflect a larger truth. War rewards, pragmatic thinking, speed of adaptation, and willingness to try half-baked ideas if they might reduce risk or create opportunities. Recovery, repair, and the unsung logistics core. On paper, a tank battalion is visible when it fights. Less visible are the workshops, maintenance depots, spare part pipelines, and recovery squadrons that keep machines in service. Some considerations: recovery vehicles and trained recovery crews were vital. A damaged tank left in the field was lost capability and required resources to replace. Field workshops, mobile and rear area, could fix engines, replace turrets, and do battle damage repair. The quicker the turnaround, the higher the force's sustained combat power. Railheads, docks, and port facilities form the backbone of armored operations on strategic scales. A unit without fuel, ammunition, or spares is simply a bluff. Psychology and morale, flame, noise, and the smell of battle. Weapons are tools, but their psychological effects are real and sometimes decisive. Flame weapons are a blunt instrument. They destroy morale by making the prospect of continuing to hold a position intolerable. Loud engines, the sudden silence after a shell hits, the sight of a disabled vehicle all affect morale. Commanders use these effects consciously. Maintaining a reputation for aggressive firepower could deter a counterattack in places where the opponent preferred to avoid losses. Conversely, the loss of a brigade's veteran tank crews in a failed assault could have an outsized, demoralizing effect across a front. Post-war legacies and the shape of future armored forces. World War II's tank experience fed post-war design and doctrine. ChatGPT 5, Gemini, Midjourney, the 11th of March 2025, 1112. The main battle tank, MBT concept. Armies moved away from separate classes of light, medium, and heavy tanks toward a single design that combined good mobility, protection, and firepower. This reflected both technological advances and the realities of logistics and combined arms. Armor protection evolved, better metallurgy, composite layers, and eventually active defense systems. Designers absorbed World War II lessons about ammunition, stowage, and crew survivability. Combined arms thinking hardened. Tanks were never again seen as standalone solution. Rather, they were one node in a network that included reconnaissance, artillery, aviation, and electronic communication. A few final composite vignettes and reflections. A river crossing under fire, composite plausible. Bridging river lines is the kind of operation that tests planning, engineering, and nerves. An armored column arrives at a bridge that was only partially blown. Engineers race to shore up the span while smoke screens and mortar fire provide cover. Shermans form two echelons, one to provide direct, suppressive fire, another prepared to exploit once the engineers clear the way. Artillery adjusts fire to keep the enemy's heads down. The operation succeeds because of timing, the engineer's readiness, and the tank's ability to provide immediate fire support. A small human recovery story, composite. A night raid leaves a tank disabled near the edge of a wood. Rather than leave it, a young corporal organizes a recovery party with a nosy jeep, a chain winch, and a borrowed tractor. Under cover of darkness and guided by a whispered flashlight, they hook on and pull the tank 3 miles to a field workshop. By the next day, it is patched and fighting. Small acts of initiative like that preserve combat power, and they are often the unsung backbone of a campaign. Closing synthesis. What matters in armor, then and now. If you've read this far, you'll have seen a few repeating themes. Human decisions trump single attribute superiority. A gun with higher caliber matters less than the commander's choice of position, the crew's discipline, or the maintenance regimen. Logistics and repair are as decisive as gunnery. A fleet of average tanks that are ready to fight often beats a few superb machines that sit idle. Adaptation wins. The fastest adopters of new tactics, small engineering fixes, and deceptive measures gained disproportionate advantages. Combined arms integration is essential. Tanks must operate with infantry, artillery, engineers, and air support to exploit their strengths and mitigate weaknesses.